In these three examples, we are going to be doing the derivative of these, which is we're going to be using the chain rule. And the reason we're using a chain rule is because we have a function within a function. So we have a composition. All exponentials, all logs, and all trigs are going to have functions within functions. We're going to have to apply the chain rule to them. And so this one is going to be a little bit more work, and we'll kind of talk about why that is when we go through it. It's not the calc that's going to get you. It's going to be the algebra that you got to do afterwards. So we'll start off with doing the derivative of the outside. So that 3 comes down. Nothing changes on the inside. Oops. T to the second over 3 t squared plus 2. And then we'll drop that down. But then here's where the work comes, is that when we do the derivative of a chain rule, that we have to use a chain rule is power comes down. So we do the derivative of the outside. Now it's going to be the derivative times the derivative of the inside. And we have a quotient rule that we have to deal with on this. So we have the derivative of the top. And so we're going to have a fraction out of this. So the derivative of the top is going to be 10t times the bottom, 3t squared plus 2, minus the top, 5t squared, times the derivative of the bottom, which is 6t. And then, sneaking into that other one, all over the bottom squared. So the bottom squared is 3t squared plus 2 squared. All right, so I need to put all this stuff together. So let me just kind of keep track of it, and then we're going to write it on our second step here. So we have, that's going to be a 30 t to the third when I distribute it there, minus 20t, plus 20t. And then these two will go together, so minus 30t cubed. Well, that's good. Those will go away. So that's what I have left on the top. All right, so let's try to figure out what we got going on. We have this fraction, right? So that fraction, if I try to start to put some of this stuff together, I'm going to have 3 times, and I'm going to be squaring this and squaring this. So that's 25 t to the fourth. And then this piece, t squared plus 2, also got squared, times, if I put all that together, I got a 20t over this same piece squared. All right, so it's coming together. So we have now, we put all this together, that's 75, 75 times 20, 75 times 2 is 150 plus a 0, 1,500. And then 5 t's, t to the fifth. And then we have the exact same piece, so we can clump them together. 3t squared plus 2 to the fourth power, because we have 2 of them there and 2 of them there. And that is our final answer on that one. So, like I said, it's not the calc usually that gets you. This is about as ugly as it gets. A lot of times it's the algebra that it takes to finish the problem. All right, this one. This one is good. This one's very straightforward, actually, is that when you have an exponential, you're looking at this is your chain rule is going to be the derivative is going to be, remember, let me just write it out generically, that if you have a e to the x, your derivative of it technically is a chain rule, and it is e to the x times the derivative of the exponent is what we're looking to do. Okay, so we're going to have itself e to the negative 3x times the derivative of the exponent, which is negative 3. So just cleaning it up is me just putting that in the front. And it looks like that. So exponentials are not bad, but they are always a chain rule. Even if it's the most basic one, in the past, we would just say it's itself. It is, because the derivative of x is just 1, but that's not always going to be the case. All right, so it potentially has a little bit more to it. And then the last one. The last one, rewriting this, I know what sine cubed is, but in order for me to do the derivative, I'm going to need to rewrite this a little bit different. So this cube is applied to the whole thing. So I have sine of 4x squared, and that whole thing is cubed. So technically, we have a function within a function within a function. All right, so we got a chain rule that's going to be applied a couple of different times. So let's work through outside. So if we do the derivative of the outside, 3 comes down, and nothing changes, square. So nothing changes on the inside. So sine 4x squared, change the inside. All right, so derivative of the outside times derivative of the inside. So the derivative of the inside is derivative of sine is cosine. So now we have another chain rule. Right, so now we're kind of done with this and treating this as what's the derivative of the outside times the inside. So derivative 4x squared, and then times the derivative of the inside, 8x. Okay, so we'll do that again. Derivative of the outside comes down, right? And then the inside doesn't change. And then we're going to be doing the derivative of the inside, but it is its own chain rule. So the derivative of the inside is cosine 4x squared. And then now we're left with the derivative of the inside of that. So a little bit of cleanup is we can take and combine the 8 and the 3x, making 24x. And then I do have this piece squared, so times sine squared of 4x squared times cosine 4x squared. Right. And then that was a chain rule that had a chain rule within the chain. So those are a couple different more examples that involve chain rule, a little bit more complex than some of the other ones, but those are different looks.